So it's 51. Huh? Okay, so we're about to begin. Actually, I'm just waiting for our AD, but since we're over time, we'll stop waiting and go ahead and start the meeting. So this is the Mpls working group meeting in Bangkok. This is the first of two meetings. We have another meeting tomorrow morning, the second session. You can do the next slide. Yeah, so this is a note well. So I'm Loa Anderson, this is Nick Lehman, and our secretary, Tarek Saad, is up here to the right. This is a note well. Basically, I think of it as everything you say, do, and write in a IETF context is subject to the become black? Now we're back. It's subject to any rules that apply to IETF. So if you don't disclose anything you don't want to disclose, that's probably the advice I have. Okay. So the administrative information is that we have an audio streaming. That means even if you shout loud, you probably have to shout into the mic, otherwise the people remotely won't hear you. So speak using the microphones and state your name before speaking. We have a data tracker that takes you to the Mpls working group. Actually, data tracker is more and more replacing what we had before as milestones. Tarek, on minute takers, that's okay, thank you. We will have two presentations suddenly on MeetEcho or remotely. That's actually the first time we're doing that, I think. Maybe George did one at one point in time, I don't remember. You have the URL for the online agenda and the slides. And then we go, this is the agenda. It's not that crowded, but it actually fills out to the 2 hours today and 1 hour tomorrow. And I'm kind of eager to get going. So if no one has a comment on the agenda, this is how we were going to work. So no agenda bashing. Okay, thanks. There are blue sheets. They are with Himanshu and Tarek, sign and move. And when they get to the back of a room, turn them back to the working group chairs. This is my bad conscience. I promised at the last meeting to actually look at it, and I totally forgot. So this errata, I need to sit down with my co-authors on that RFC and look at it. I think there is some type of level, it's true, though I'm not sure that I want to go for the take text out. I think I would like to modify the text, but we will discuss that and respond to the errata. Is Stuart in the room? No. Okay. Go on. We have had no liaisons, no outgoing, no incoming. We also have had no new RFCs, and that is, Tarek, do you remember? This is the second meeting in a row where we don't have a new RFC. We had one last time. Okay, so this is the first time that we don't have a new RFC. On the other hand, we have 4 documents with the IESG, and I think that at least the LSP lag multipath draft should be fairly close to approval and publication. We have one document, the Mpls RSVP shared labels. Did I get the name right? Yeah. And that is actually requested publication for that as of yesterday. We have new working group documents. The newest is the one at the bottom, the draft IETF Mpls SSC encapsulation, also approved, accepted as a working group a little bit earlier, but actually posted this week. Okay. We have a number of documents that has been updated. So the legend here is that anything in blue will be on the agenda. We have a updated working group that is still is waiting for the write-up just before publication request, and that's the Mpls RI RSVP FRR. The other ones are either on the agenda or in the queue to I shouldn't say that. The draft IETF Mpls SFC is in working group last call, and it will end in about a week. Not a month ago, but we fixed that. The rest are the Mpls RMR and MP is next in line to go to working group last call, and then after that we will do the Mpls SR over IP. So quite busy. Please review and send comments. Yep, I'm happy with that. And then we have a number of new individual drafts. All of them are on the agenda, so no need to talk about them. And then we have updated individual drafts. I think there is. So help me, Adrian, help me. Draft SU Mpls SR over IP. That is a document that actually was submerged into the working group document, so that should be removed. Otherwise, I don't have much to say about this. They are coming along quite nicely. And then there are documents that have been there for a while and has not been updated since last time. So, Greg, you had a document in BFD, I think, that you wanted to give a heads up to the Mpls working group.
Yes.
Yeah.
Thank you. So this document was presented.
Greg, to be, even if I say your name, you should actually
Okay.
start
Yes.
saying.
Sure. Thank you. Apologize. Greg Mirsky, ZT. This document that we'll refer to describes applicability of BFD demand mode for MPLS point-to-point OSP. And it's in BFD working group adoption call, and call closes this Friday. I'm not sure about what time zone working group chairs will consider, but I'll appreciate reviews and comments to BFD working group and to MPLS working group, because applicability and substance of the document is for MPLS data plane.
Okay, thank you. Then we have at least one progress report. That's IETF Mpls summary FRR or CBT. The document has been updated, and authors claim better now. No. Don't have any. Okay, here we are back again. So the draft IETF Mpls summary FRR RCPT document has been updated. Authors claim that it's ready for working group last call, so we will start the process. You will see an IPR poll shortly and all the other steps. Okay. We have a number document where we don't have status reports. Some of them are because we're not expecting one, like the BFP directive, because that is with the chairs. So we are still sorting out issues around that document. The MLDP MEB, I think it's about the 6th time it goes to close to expiring. And we are trying to push it, but it seems like there's something that doesn't really work. Draft IETF Mpls SSC is in working group last call, so we're not expecting an update on that. And then we have two documents on the synonymous flow labels that we haven't received the report on. Okay, next. Okay, so now I'm going to take a few minutes to, I don't know what I call it, brood over. So we have a document that is RFC 7322. It's called the RFC Style Guide. And it's pretty much the law when it comes to how you structure a RFC. And as all laws, it's open for some negotiation, but if you actually follow that structure defined in that document, you won't have any problem. There's some fixed points the way we don't give. So don't try to be too inventive. Follow the document structure and write a technical invention. Don't do a document invention. There are one thing that is I have taken as a fixed one, that there is only 20 lines in an abstract. It's no longer true, because I actually seen an RFC being published with 21 lines. So, but keep the abstract shorter than 20 lines or 20 lines, but it should also include enough information to actually be understandable. This document, abstract, this document defines a new protocol, period. Won't go through a a review by working group chairs or ISG. You need to, something I had said before is that we can, if you think about your next manager in the hierarchy, write the abstract so that person actually understands what it's all about. And you have 20 lines to do it. Okay, next. Then we have the style guide. One of the most common comment we have on any ID is that, okay, first time you use an abbreviation, you need to expand it. And it's amazing actually how often we miss that. Go look at the abbreviation list, because that has two types of entries. If you see Mpls star, it means that you don't need to expand Mpls. If you see LSP without the star, you must expand it the first time you are using it. And the reason that LSP is not classified as well known is that there are, I think, 3 different other uses of LSP. So we don't know which one you mean, so you need to expand it anyway. So there are duplicates and triplicates. We actually put SID, not as a well-known, but we put SID in, and I think we now have 4 different expansions of SID. So it's not only segment ID, it's a couple of others that I don't remember. Okay. I have discovered that I'm writing, I'm starting to use two abbreviations fairly frequently. WGLC has been there for some time. It means working group last call. And I probably will start using it more frequently. We also have working group adoption poll, WGAP. I have tried to expand it when I use it, but I know that I start using WGAP as a abbreviation in mails that goes out to the working group. So you should be aware of what it means. So those are not really local to the Mpls working group, but this is how we'll be probably using it more frequently in the future. Next one. So we have questions frequently asked about working group last call and adoption polls. The first one is that I actually got from a long-timer, former AD and former IAB member, and asked me, as a co-author, do I need to respond? And the answer is a co-author does not need to respond to either a working group last call or a adoption poll. It doesn't change anything. I already know that an author actually supports the document, so I don't need to have that information twice or 6 times if there are 6 authors. The other question, may a co-author respond? Yes, you can do that. It doesn't hurt. So one reason I heard is that co-authors tend to respond to adoption polls and working group last call when there is low traffic on that subject. So if you send another mail saying working group last call on drafts and so, then you increase the traffic and increase the awareness of what's going on. And I say you can do that. It's not very efficient. It would be much more efficient if you actually thought about people that has not responded, having an interest in the area, ask them to review and comment, because then you actually get a possibility to improve the document. Okay. IPR polls. So we do that twice, before adoption poll and before last call. Authors and co-authors are required to respond. And you're also required to respond. It's not on the list, but you're also required to respond if you know about a IPR that related to the draft, that particular draft. And also, and like Andy should know, if someone writes in a acknowledgement section that we would like to thank Mr. Mpls for contributing text, that will trigger a mail from working group chairs to that person in particular, asking him or her to actually respond to the, because I don't know what text you actually added, and I don't know what type of IPRs you can actually promote that way. So that's the reason. And we do not conclude IPR polls on time. Well, we always do conclude them on time, but it's not a specific date. We actually wait for everyone that is supposed to respond, actually to respond to the IPR poll. So what happens if someone don't respond? Well, that's a good question. Okay, there is a escape clause, but so far the Mpls working group has not found it necessary to use it. What we probably do is actually send a mail to what we planned to do last time we were close to it was send a mail to the working group mailing list and say, this person has not responded. Is it okay to go ahead doing the working group adoption or conclude the working group, start the working group last call anyway? One thing that I want to happen, it's not necessary, you're not required according to IETF processes, but when we go from a individual document where you have an IPR disclosed to a working group document, I'd like to see an update, changing nothing but the name for that IPR. It's fairly easy to do and doesn't cost that much, but it's very helpful. Okay. And then we have to, and I'm bringing that up because we have I have had a misunderstanding a couple of times. We have a preliminary agenda that we need to publish before the working group meeting at a certain date. We always miss that by 2 and 3 days, but it's preliminary anyway. And then we have a final agenda that we need to post at a certain date, about a week before the meeting. This is all done on a best effort basis. So the preliminary agenda is an approximation. We list all the requests for slot we have and all the requests for slot that we think we would like. So the preliminary agenda doesn't guarantee you time in the face-to-face meeting. The final agenda is at the time posted, the best estimate that what actually will happen. Though the final agenda is actually set when we do the agenda bashing at the meeting. So the final is kind of semi-final. Yeah, okay. Anything more? Then we have my favorite list. Those are the sleeping beauties. I have 3 pages of this. So this is documents that we have had posted to the working group that has for some reason stalled. I know the list is wrong in 2 different ways. first of all, it actually includes documents that still are moving, and they should probably be taken out. It also does not include all the documents that we could list here. So it's, again, an approximation. What I want you to do, or I want the working group members to do, is actually take a look at this list and see if you have a document here that you posted like 2.5 years ago, when you find it they're still relevant. I would like to progress it. Come and talk to us. And if you find the other thing, I posted a document like 3 years ago and it's dead, and it should be dead, tell us so we can kill it. So Nick, you can just go through the. There's.
Okay, hello.
Hello.
Hello. Can I have a comment on this document list?
Sure.
Yeah, actually on the third row, sorry, the previous slide, the first slide.
Slide number 2.
No, the Sleeping Beauty one. So you have listed document MLDP multi-topology there. I think it's no more sleeping or dormant document. It was presented to IETF ago. We have resurrected it. ICE has presented in London.
Okay. So, Cameron, can you send me a mail on that so
Sure.
I know what the status is?
Okay, absolutely.
Okay, thanks. Oh, you're going back to the agenda. Thank you. So now we have 2 remote presentations. First is Anil.
Yeah, I have to. Just one remark for the guys in the Meet Echo. The update frequency is quite low, so it takes about 15 seconds.
Okay.
Hang on. So which one is the first one? This one, yeah. Do you see the presentation?
Yes, I can see the presentation.
Okay.
Yeah. Good afternoon, everyone. Let me briefly introduce myself. My name is Anil Kumar Hassan. I am delighted to be part of IETF 103 as a remote participant. Thanks, Chair, for the opportunity. I would like to talk to you about the new draft LDP identifier name. My objective today is to get your point of view on this draft. We'll be very happy to receive your suggestions and comments. So, in a scaled up topology with multiple neighbors, it might be difficult to map label bindings received from multiple LSR IDs having different namespace. So having human understandable names mapped to LSR ID would be very helpful in reading through the information. So the purpose of this draft is to exchange LDP identifier name through LDP protocol itself. So the operators could easily map the identifier to name. So as we all know, LDP identifier is 6 bytes data, 4 bytes is IP address, and 2 bytes is label space, which is part of every LDP PDU header. So there are multiple ways to derive or obtain LDP identifier name. Obviously, one is a static configuration at each device. So other one is using centralized location, which maintains a LDP ID, LSR ID to label, LSR ID to name mapping. And it has its own advantages and disadvantages. So one way could be DNS server or SDN controller or something, where NMS. So one of the reasons could be like reachability of network problems to reach the DNS or controller or NMS, the response time for that, and then if there is an added dependency on that controller or centralized device. So, and one more thing is like operators could want to have a different name mapping to the ID at the runtime. So, and it is easier to make changes directly on the router instead. So what we are proposing is a protocol to carry a label identifier to a name mapping in a TLB. This draft introduces a new LDP identifier named TLB as an optional parameter as part of LDP hello message, similar to IP4 transport address TLB. So LDP identifier name will be encoded as a ASCII string, which is the string will be mapped to both LSR ID, I mean IP4 address plus label space together. We can give a one string. User can decide what would be the string. So we just kept a plain TLV. I mean, this is a simple proposal with introducing a new optional TLV in a hello message. So we would like to hear from you whether are we in a is this useful or like this extension is the right way, right approach, or any further suggestions to improve the document? So, I mean, this is similar to the IP4 transport address TLV, so it's optional. So if a new device doesn't understand this TLV, you can ignore this TLV and continue with the process. Thank you.
Hi, Anil. This is Adrian Farrell, echoing. Yeah, thank you for the explanation. Thank you in particular for the chunk of text you put in about duplicate names, because when I started reading the document, I was going, oh my God, duplicates, oh my God. And then I got down to the bit at the bottom that says what you do if two LSRs use the same name. So that's cool. I'd like you to spend some time thinking about internationalization.
Okay.
I don't, you're currently saying US ASCII, and well, where I come from, that is a problem, but probably in England and in America, it wouldn't be a problem. But I think we have to be a bit more,
Okay.
yeah, so there are a couple of RFCs out there that talk. I think if you go to the data tracker and search for internationalization, you'll get some pointers.
I got it. Thank you.
So any further questions? So, okay.
Okay, thank you.
Thank you. And we're going on to the next remote presentation. Cameron going to talk about LDP Yang and MLDP Yang. Hello, Cameron.
Do you see the presentation?
Yeah, it's coming up.
Yeah, so just say next if I should skip to the next page. But as I said, it takes like 15 to 20 seconds. So
Sure, I will do. Hey, hello everyone. My name is Kamran. For next 15, 20 minutes, I'm going to present an update to the working group for the Yang data model effort for LDP and MLDP. So let's start with LDP first. Next, please. Next slide, please.
yeah, I'm on the next slide already here in the room.
Okay, yeah, it takes time.
Yeah.
Okay, so while it's coming up, right. So we have been presenting LDP and MLDP Yang model drafts almost every IETF, an update to the drafts at least. Last IETF in Montreal, we skipped it because there was not much activity. So we are back to present both of them in this IETF. So LDP draft, just to remind everyone very quick history, we presented this in Singapore. We updated and refined a draft a bit and presented again in London. In London, we called for the working group last call. And call was initiated, thanks to chairs, in July 2018, right after the Montreal IETF. And we also received working group last call review comments from Tom Fesh. They were very useful. and we have addressed those comments and posted the new revision 5 before Bangkok. And I'm just going to take you through the changes we did in revision 5 as part of the working last call comment we received from Tom. Next slide, please. So while the next slide is coming, actually, let me, I have my own version too, so I can keep speaking. Yeah. So basically, as part of revision 5, there are two main things we did. A couple of main things. One was working group last call comments we received from Tom. We addressed those, almost all of them. Dropped an email to Tom and the working group to take a look. Some of the comments from Tom are pretty generic and not specific to this model. And he has noted that some of those misses, as well as misses, as well as some of the incorrect use, is all across many routing area Yang models. So I have a slide on that later on. We can go through that. And Loa has asked me to maybe touch upon some of those generic comments, which is useful for many other documents as well. So while I present MLDP later, you'll notice that we also applied some of those comments on MLDP Yang, although Tom hasn't reviewed them, but we proactively have applied those as well. So this is working class comment from Tom, and we also added some of the JSON data examples in our model. That was as part of the MLDP review by AC, and we backported that review to LDP as well. So these are the main two changes, major changes in this revision 5 over revision 4. Next slide, please.
Yeah.
Okay, so I'll go through generic comments that Tom has on the draft. I'm just summarizing some of them. So one main comment I think, as I observed, was that specification of requirement language that we have, it is still using old boilerplate where we were not referencing RFC 8174. And the actual language, which I have highlighted in italic later on. So this is the actual text that we have to add in specification of the requirement. So I found it all across my Yang and other documents in IETF. So anything that I have touched and updated, I have updated. But I noticed and I looked at around, all of the documents are still using old boilerplate as well. So I think this is in general true for many documents in routing area. So we need to fix that. Second main comment was that although we are using an NMDA-based Yang, and we haven't explicitly called out in abstract, it is important enough to be called out in abstract. We were missing notes to RFC editor, especially if this document is close to a publication. I think it's time that a document should have a proper RFC editor notes, so that to make their job easier, to replace the text, like for example RFC number text, Yang module file names, and revision of the date of the revisions of the module with the dates of the publication and whatnot. So in general, all our module .yang as well as our document was missing those notes, and then we did not have any revision or version statement at all in our Yang. So by default, it becomes Yang 1.0, although we were complying to Yang 1.1. So these were a few comments. Next slide, please. Right, and then few more comments that in our imported modules in our Yang, there was no reference statement, and then of course, since reference was missing, we were also missing the respective RFCs or the document from the normative references. We were using tree diagram but not referencing its RFC. A security consideration section was not conformant to RFC 6087 base. And ENS consideration section was either missing in some cases, or in LDP cases, it was actually missing, and we had to add the full ENS consideration section. So these are all comments on our MLDP, so over LDP working group last call. And as you can notice, that most of them are pretty much applicable to any other Yang, which may or may not have, which may or may not have missed some of those. So that's these were the comments from Tom. Loa, you want to add anything now, or you want to take questions later on this?
I have one question for you. I know you sent mail to the people making comments, Have you seen any responses?
I don't recall. I think I had also one private email to Tom on asking something. I think has seen response, but I don't think I have seen any response on the alias.
Okay.
This was posted right on I think IETF cutoff date. This draft revision.
So any comments from the group? Questions? Okay, so I think we're ready to go on.
Okay, sure. Next slide, please.
Yeah.
So I think the previous slide I tried to cover what Tom has captured, and of course we addressed all those comments in our revision 5. We added proper references, added lots of RFC editor notes, added tree diagram references. Active security consideration section is much enhanced now. It might still be lacking some of the text that might we might have to revisit and update as part of the security review. But right now it's in much better shape than the original security section. ENR section was totally missing, so that has been updated and looks good. And we added proper references to the latest revision of the normative references and informative references we are using. Next slide, please.
Yeah.
So JSON example. This was not part of the review comment from Tom, but this was a review comment on an MLDP draft, early review by AC. So we have added there. So we also kind of applied that to LDP draft. As an example, this is just an example, but we have more JSON example in our document. So this just shows how you see a peer state, different parameters of the peer. This is so we have added this as an appendix in the document, just for a reference. And I think this is useful information to have in a Yang model to people to visualize how the Yang will look like. And last slide, please.
Yes.
So as a next step, I think we have addressed all the working to last call comment. We haven't seen an explicit act from Tom or others that looks good. But at this point in time, authors believe that I think this document is ready to go to next step, which is basically publishing. Unless there's more review comment, we will be happy to address those and respin any new revision. But for now, from our side, I think we're waiting as a next step for the publication.
So Cameron, a little bit more detailed next steps. What happens is that we will see a Shepherd write-up that we actually let the authors review and approve before we actually request publication. And then there will follow a AD and ISD review before approval. And
Yeah,
then the
so-
others together.
Yeah, sorry, I should have said that. When I mean publication, I mean go to the publication logistic for the first step, which is, you're right, the Shepherd review and whatnot.
So I'm clearly biased on this document. But I have one question that I actually need to ask, and that is, are the changes we made to the document within what we normally do as an update to the working group last call, or are they that big that we actually should do a short working group last call again? Any opinion? I see people shaking their head. Anyone that want to stand up and say we are ready to go?
I would be biased.
Okay, can I have your name, please?
My answer is on the way to Mike.
So, Himanshu from Siena. I will be biased as well because I'm also a co-author, but it's ready to go.
Okay. Any other opinions? Okay, thank you. So Nick has to write a Shepherd's write-up.
Yeah, the second one.
Okay.
There's another one waiting, but yeah.
And the next document is the MLDP one.
Yeah, next slide, please.
I'm now on the history slide.
Oh, okay, you're already there. Okay, so let's go to the second part of this presentation. So it's MLDP Yang. It's also revision 5. So LDP and MLDP Yang are going hand in hand with respect to our upgrades and revision. So just again reminding everyone history about MLDP, recent history. These documents have been around for a good 4 or 5 years now, at least since Hawaii, if I remember correctly. So recent history is that we posted MLDP revision 3 IETF in Singapore. We received Yang Doctor early review by AC around December time, and we posted. Sorry, I don't see the slide anymore, but I can continue. Okay, I can see it now. We posted revision 4 before Montreal, where. Can you guys still hear me?
Yes, yeah.
Okay. The slide somehow is gone, what I was seeing, but I can continue on my own version, I guess. Okay, yeah. So, right. So we posted the revision 4, but this was a minor update. Somehow we had missed AC email and we did not update it until later. So we posted a revision 5 right before IETF 103 in Bangkok, and we addressed AC comments. And actually, on that front, I replied in detail to AC comment and took comment by comment and replied to AC. And I think I had seen acknowledgement from AC and thanking and acknowledging that the changes we have made. And the AC has done a wonderful job. He was very detailed. He helped improve the document quite a lot. So on behalf of author, I'd like to thank you, AC, for a very detailed Yang Doctor review of the document. Is AC in the room?
I don't think so.
No.
Okay, all right. So next slide, please.
Yeah.
So as I said, we basically revision 5 addresses review comments from AC. If you do the diff between 4 and 5, you will see quite a bit of changes in the text as well as in the .yang file. And I also alluded in LDP presentation that we also applied comments, generic comments from Tom that were LDP on LDP document. We also applied those in MLDP document. So we believe that MLDP document working group last call and the next level of revision will be much better because we have already proactively enhanced the document for the reviewers going forward. Next slide, please. So basically, as in terms of what we address from Yang Doctors, we revised the security consideration section, added JSON example for configuration operational state. Our descriptions were not very clear, so we in Yang module we clarified those. We added missing normative references, renamed some of the leaves which were causing some confusion to the reader, and also clean up some grouping as suggested by AC. And we also took lots of AC's updated text and applied to the document. Next slide, please.
Yes.
And then the second part of the changes are we applied Tom comments on MLDP as well proactively, added proper references, added notes to RFC editor, mentioned that we're using Yang revision 1.1. We added references to the tree diagram RFC and other updates to the document. Next step, please.
Yes.
So as a next step for this document for MLDP Yang, we are looking for any further reviews of the document, unless there's other reviews and then there's some more revisions we have to update. But I think we believe that since we have applied very detailed comments from AC on the document, as well as actively applied LDP working group last call comment on MLDP draft as well, our MLDP Yang draft is also in very good shape, and authors and co-authors believe that we should be ready for a working group last call on this document as well. I will leave up to chairs to discuss this either now or on the mailing list. But this is, I think, from our side, this is the next step for this document. That was my last slide. Any questions?
Questions? We're not really willing to discuss young models here. Sorry. So next step is probably you see an IPR poll, and then we run through the working group last call process. I would like to say something. It's a pity that Tom Petch is not here. Well, he's normally not here, so it's not a surprise. But I would like to say that we very much appreciate the reviews that Tom Petch has done across the routing area and a number of Yang models, and actually work to kind of create a conformity. Well, they look the same now because we applied the comments that I think everyone actually applied the comments that they got from Tom, and it's very much appreciated. Okay, are we done? Thank you, Cameron.
Thank you.
Thank you.
Now it's Tarek.
You can do it on your own.
Okay, sure.
Good afternoon. You can hear me well? Okay. My name is Tarek, and I'm giving you a quick update on the two Yang drafts. The first one is the MPLS-based Yang draft that puts the cornerstone for other augmentations of MPLS protocols. And the second one is for MPLS static LSVs, which is augmenting the MPLS base. So I don't have many slides, but as I go through, I will describe what we've done in terms of the updates to the drafts, and then I'll close with some next steps. So, okay. The drafts have undergone a Yang doctor review, and we got quite a few of comments. We did clean up the document in general, made editorial changes and some nits that were pointed out by Tom Petch, basically. I did mention his name on the next slide, but it was Tom that he reviewed our Yang model as well on the drafts. We did proactive job of, we did notice that the LDP model and the MLDP model were being reviewed, and there were generic comments, as Kamran was saying, that are applicable to pretty much all the Yang models that are being published at IETF. So we took care of those comments that are applicable to our drafts, and we addressed them, although they were not called out explicitly. The ones that were called out, and we did put references where it was missing for imported modules. We did migrate to the NMDA, so we're now compliant with that. And we put reference for NMDA as well, which was missing. And we added and updated, actually, the security consideration sections. One detail, we did import this common type that is defined in the routing common types MPLS label stack. So we found no reason to redefine it in our model, and we're reusing that. Pretty much what Kamran presented, the generic comments were applicable to our model. I'm not going to go through them, but we took care of those. So in terms of next steps, we sent out an email to Tom Petch, the Yang doctor who gave us the comments, to acknowledge that he has no further comments. Once we have that acknowledgement, we think the drafts can progress for working group last call and make its way to the publication. Any questions? I'll be happy to answer. Thank you.
Thanks.
Thanks.
Thank you, Tarek. Actually, who requested the Yang doctor review here? It was okay. It's such a long time ago that I forgot about it. Okay, so those 4 documents are basically 80% of the Yang models that we currently have in the MPLS working group. We also have a document that is, LSP ping Yang. And the authors of that document has actually requested working group adoption. So we will start that process shortly after this meeting. We have many such polls and working group last calls going out, so there will be a slight delay. So next up is Chandra. And we actually given you 5 minutes more than you requested. If you want to use them, please do. You have the slide.
Yeah, all the slides. Just press. Yeah, the arrow. No, the other direction.
This
Yeah.
is next.
Next to the next, yeah.
I think that's a point.
The pointer, yeah.
Yeah.
Good afternoon. My name is Shraddha and I'll be presenting 2 drafts. One is on EPE OAM and another is TTL handling for SRTE paths on behalf of co-authors of this draft. So this, the segment routing central EPE draft defines SIDs for the EPE use case. So here we have 2 different ASs connected with ASBR, links between ASBRs, and the central EPE draft defines different types of SIDs to be able to use, send traffic on these links and choose either load balancing or single links or a set of load balancing links. So when there's a deployment that uses this EPE SIDs, there is a operational requirement that to be able to do ping and trace route across these links and these validate the control plane and data plane for these SIDs. So it's useful to have this cross AS fault localization in case there are problems in control plane and forwarding plane programming for these SIDs. So we're trying to see 2 use cases. One use case maybe the 2 ASs belong to a single operator and they have been segregated because of easier operational and maintenance reasons. And there could be another use case where the 2 ASs belong to 2 different, completely 2 different customers. So what we really need is the FEC stack definition for EPE SIDs. So we have this peer node SID and peer adjacency SID. So for OAM to work, we need FEC stack definitions. So the definition looks like, so we have new target FEC stack TLV definition. So this one defines the FEC stack for both node SID and adjacency SID. So the information to be validated is pretty similar for both node SIDs and adjacency SID. So I thought probably, having just one code point allocated for them is good enough. So we have the local AS number, remote AS number, and local interface address, remote interface address, and advertising BGP router ID and receiving BGP router ID. That's the definition of the FEC for peer node SID and adjacency SID. So it supports both IPv4 and IPv6, and the length would decide what exactly is being used, whether it's for IPv4 or IPv6. So peer set SID defines load balancing requirement. Single label would load balance across multiple links belonging to different ASs. The links could belong to, could be going to different ASs. So there is this number of elements in the set. The link representation is exactly same as before, but you could represent those links multiple times in this target FEC. So validation, there are two kinds of validations that may be necessary. One where we can, operator can allow the cross AS validation, and another case where the cross AS validation is not allowed because the OAM packet is not allowed to reach the other side. So that can be controlled via configuration. So in case where the local configuration allows cross AS validation, the validation would be exactly similar as defined in 8287. Whereas if the cross AS validation is not allowed, then the local AS would return the return code as egress while validating these sets. So next steps, request feedback from working group, especially for the target FEC stack definition, and then probably working group adoption because it's a very simple and basic extension too. Any comments?
Any questions? Okay. So I have a question on the last slide. And that is probably just me. When you say working group adoption, ? What do you mean? Is it actually request to start looking if we should go through the working group adoption process?
Yeah. Can we start? That's the question.
Okay. Can I ask how many has actually read this draft? There are a handful or a little bit more. How many of you who has read it, think it's ready to start things like Mpls RT review and the general process to make it go to working group adoption? About the same number, a little bit less. Okay.
So this is a draft about handling TTL procedures for SRTE paths. So stops working.
Doesn't work? Oh. Yeah, no.
Oh, okay. So the problem that we are looking at is we have to trace a SRTE path. So let's assume the path is represented using two labels on the label stack, 1004 and 1005. So we have this network with R1 to R5, and then the intent is to send the traffic from R1 to R4 and then R4 to R5. So those are represented using two nodes at 1004 and 1005. So when MPLS traceroute procedure has to be supported for this label stack, so based on RFC 8287, it suggests that when you start tracing this this tunnel, you have to start with all the outer label, the topmost to start with 1, and then all the inner labels set to 0. So so the step 1, we set 1004 to 1, and then 1005 to 0, and then packet is sent to R2. So on R2, the TTL check fails for the out TTL. So the packet goes to R2, and then R2 sends an MPLS echo reply, which says, so based on what is programmed on R2, it says I am the transit for 1004. So the next step, when R1 receives a echo reply that R2 is transit, then it increments the TTL for 1004. So now in the second step, it becomes okay. In the second step, the TTL becomes 2 for 1004 label, and then packet is sent out from R1. So R2 decrements the TTL. It goes to R3, and R3 again decrements the TTL, which makes the TTL for label 1004 to 0. So R3 gets the packet, and then it sends an echo reply. So R3 is PHP for label 1004. So it sends the echo reply as I am the transit. So the next step, R1 increments the TTL of 1004 to 3, and then again sends back the packet on the wire. And then now in this step, it reaches R4. So it reaches R3. So R3 is popping the label. So 1004 is removed from the label stack. And then packet is sent to R4. When it comes on R4, there's only one label 1005. And the TTL here is 0 because initially the TTL was set to 0 for label 1005. So in this case, the packet may be punted up to the RE, or it may not be based on implementation. It may be dropped, or it may be rate limited. Let's assume that packet gets to R4 processes, and then see what will be the problem even if R4 processes. So R4 processes the packet, and it says I am the egress for this FEC, which is 4.4.4.4, and then sends that return code to R1 in the MPLS echo reply. So R1 now increments the TTL of 1005 to 1, and then it starts tracing and sets the outer. So it has reached the egress for that tunnel represented by label 1004. So it sets that to 255, and then it starts sending the packet. So in this case, when the packet reaches R4, it's again because the TTL is 1, so it again expires on R4. So packet gets punted to R4. But our expectation was packet should reach R5 in this step. So that's the problem in short pipe model, the short pipe model where the TTL is not getting copied. And the question, Adrian?
Can I do a question about the short pipe before you go on to the other ones? On the step 3, that one. Ooh, there you have 2 step 3s. The next step 3, that one, yes. Why do you've established the top label TTL span because you got to the end of it, so you know the TTL for the top label that will always work. Why do you suddenly change that up to 255 and not stick with the number that you know, so that if something changes for some reason in the network, you'll get some more information back?
Yeah, but you already had traced up to the end of the tunnel, right? So you know that up to this point, all that you have programmed, the control plane and data plane is just fine, right? So it doesn't really make any difference.
No, I guess not, except now you have to actually change 2 things in your source packet rather than just 1 thing. So if you look at the previous slide of step 3, there the setting the TTL to 3 gets you all the way that you needed to go. So there's no need ever to change that 3 again in any of your processing.
Yeah, that's true. Yes. RFC 8287, I guess, specifies that the outer tunnels are set to 255 and the inner tunnels, the tunnels you're tracing goes from 1 to starts with 1, and the inner ones are set to 0. So the problem with uniform model, so we have first step same, no difference, comes to R2 and then gets an echo reply. Step 2 comes to R3, gets an echo reply, same, no difference. Step 3 where R3 pops the label and R4 gets the packet. So uniform model generally copies the label from top label to bottom label, but in this case it does not get copied. As we see, the top label, that 1004, has a TTL of 1 when it is just to be popped, and the bottom label 1005 has the label 0. So generally, MPLS TTL copy mechanisms from top label to bottom label, they do not copy the outer tunnel TTL to the inner TTL if the inner TTL is lower. This is done to prevent packets getting looped. If it's an MPLS data packet, so you know that if you have set a TTL to 1, then you expect that it's only 1 hop. So that's the reason if it doesn't get copied to a label which is inner label and which has a lower TTL. I couldn't find any reference in any of the standards, probably didn't make it to any standard, but it's general practice followed by all MPLS implementations. So the problem we are looking at is same as with the short pipe model, because it's basically the bottom label has a 0 TTL. So all we need as in a solution is for PHP router to say that I am PHP, and then when ingress knows that it has reached the PHP, it has to increment the inner label TTL to 1 instead of waiting till the packet reaches the egress. So let's see what happens when we do that. So in this, the step 1 remains same, no change. Step 2 remains change. The only change is R3 will inform R1 that it is PHP because it's popping the label. And then when it does that, R1 will increment the TTL of the next label, and so when the packet reaches R3, even though the top label is popped, we have the bottom label with the TTL of 1. So it goes to R4 and then gets punted up to the RE, and then R4 says I am egress, and then when it says egress, R1 will increment the next label TTL to 2. So all this works fine. So there could have been 2 possibilities how R3 would inform that it is PHP. So one could be the return code, introducing a new return code, but that would make it backward incompatible. So if some R1 does not understand that return code, then it would not, the behavior, it would cause interop issues. So the proposal is to put the in the DS flags in the DD map TLV that R3 sends that it's a penultimate hop router, which is a P bit, new bit introduced in the penultimate hop router. And then that indicates to R1 that, it's a PHP router. So these are some of the alternate approaches evaluated to solve this problem. So PHP router itself sending egress return code. Instead of new code, PHP itself sends return code. That's one alternate approach evaluated. And then setting all inner labels to 1 instead of 0. And then setting all inner labels to 255. And then setting inner label to 2 on reaching egress. Those are the approaches. So setting the PHP router itself sending egress return code that, the tunnel is not actually being traced till the egress. So, the intent is to make sure, entire MPLS path is fine. So you have to be able to verify the control plane and data plane till the actual egress. And then PHP itself sending egress, it does not validate the last hop. And it also does not effectively detect the problems like R2 had programmed a pop operation for 1004, and if R4 had something misprogrammed something, all those cases will get missed if we do this. So this solution was discarded. And also, the intent was when we created the label stack 1004 and 1005, the intent of the operator was to figure out that the traffic should hit 1004, R4, and then go to R5. And if we do this, that won't be guaranteed. So this is not the best way to do it. And next option we evaluated was the setting inner labels to 1. So this works fine when the MPLS path, the SRT path is all the nodes on the path are programmed correctly. So setting inner label to begin with, if you set the inner label to 1, this mechanism works fine. But the problem is if there is something wrong programmed, for example, R2 is prematurely popping the label for 1004, then it may not detect this problem immediately. So for example, in the first step, the R1 has on 1004 and 1005 both set the DTL to 1. And in step 2, by mistake, let's say by mistake R2 removes the label 1004. In this case, packet reaches R3 and then the FEC stack still contains 4.4.4.4, which is a valid FEC and it's a transit for that FEC. And whereas the incoming label map is 1005. So the FEC is validated, the incoming label map is validated, and if there is no validation across these, then it won't detect. I mean, it will detect ultimately, but not in the first step. So it will go on like R3 says I'm transit, R1 will just increment the TTL and then keep incrementing the TTL, reach R3 and then keep getting transit. So the another option that we evaluated was setting all the label below the stack to 255. This mechanism obviously doesn't work well because once you reached R3, your label stack would contain 255, so you wouldn't even hit the router R4 to trace that MPLS path. So this won't work. And the last option is the when the egress is reached, instead of setting the inner label TTL to 1, set it to 2. So this also works well if the MPLS path is programmed correctly. So it would reach R4, and then once R4 is done, the next step it would reach R5. But it has the same issue that that is described for same as the setting inner labels to 1. So tracing this SRT paths, there may be already implementations that are doing one of these, like setting label to the mechanism described in this slide, or there's a mechanism described in this slide, because it kind of works. It works well for, works fine for correctly programmed path, but may not optimally detect the wrongly programmed paths. So if somebody is using those mechanisms, so the mechanism that we are proposing is not going to cause any problems if somebody is already implemented, if there are already implementations that are doing any of these mechanisms. Yes, question. So that's all I have. So pretty much.
Okay, Sam Aldrin from Google. I have many questions. Let's start with, so why does return code returning a new value will be incompatible?
Because the router which is on the ingress may not process that return code, and
because the entire mechanism is source driven, right?
Yes.
So if you have to support this, you will have to know that this return code is to be validated. So you don't have to rely on the whatever is in the network.
So thing is, let's assume some of the intermediate node is upgraded to this mechanism, and then if it is PHP, it is sending a different return code, and the ingress is not upgraded.
So because it's source driven, so you expect the source to be always up to date.
Yes, but that may not be the actual deployment scenario, right? You're just pinging.
Sure, but even in this case, right?
Yeah.
You're expecting the DD map or whatever the new acronym is has to be up to date, right? And you don't have the capability to know that particular transit or egress is up to date. you have no way to know.
Yes. So
Right.
what happens if you send the information in DD map? Is it just another bit, the
Sure.
ones who don't understand that bit will just ignore it. They won't take
Right,
any
but
action.
the thing
on
is,
it.
you'll not be able to solve the problem.
Yeah, that's true. But today it's not solved, right? I mean,
Right.
I'm not making
So that's
it
what I'm
any
saying.
bad.
So by just fixing the source, you should be able to at least be able to, instead of expecting all of the nodes in the network to actually get upgraded, right?
So not necessarily. So what I'm trying to say is this mechanism can be incremented, deployed incrementally. Like you upgrade, you don't have to worry about, some node is upgraded, some node is not upgraded. So there is going to be interop issues, right? If you're sending something in DS map, let's say you've upgraded some of the core routers and then head end is not upgraded. It's just fine. It just works how it works today. Like if you have already deployed SRTE in your network, it just works the way it is working today, right? There's no problem.
So irrespectively, so the major question I have, right?
yeah.
So we can actually discuss offline about this. My major concern is why don't you just use the TTL label for the very next label, TTL equal to 1? Not all of the labels, but just the very next label, TTL equal to 1. Why it doesn't work?
It works well if all the nodes are programmed correctly. But
Not really, right? Because you are actually sending the FEC TLV, right? Or the FEC TLV stack. So you are actually going to validate. So if you're going to pop up in any node, which is not the right node, the FEC validation will fail. So you will be able to catch that.
So in this case, the FEC is valid, right? When it comes, see, there's FEC validation and there's incoming label validation. So incoming label is different from what is FEC. And this is, if you're in your network, if it's a PHP router, this will always happen, right? The incoming label is different and your FEC is different because you have already popped the label, right? So
your validation will fail.
no, if it has to pass if it's correctly, even if it's in a correctly programmed.
No, because in the RFC, whatever, 82, whatever, right? So in that, you will, for the R3 node in your picture, you will have to, you are not supposed to send the FEC or the FEC stack TLV for the outer tunnel, right?
No,
You will
no.
only be sending the inner tunnel.
No, we can discuss that offline. My understanding is the FEC for 444 will reach up to R4, which is the real egress. And then we need to, on R4, we need to verify that, the 4444 is actually does actually belong to that router. That's my understanding, but we can discuss offline.
Okay. So totally different question. Where does the BSID falls into picture?
So let's see. So you have a BSID from R2 to R4, let's say. So for BSIDs, right, so the TTL, when you start tracing the TTL from R2, so it's a separate tunnel, right? So you would start tracing that tunnel from R2, starting from R2, right?
Right. So what's the TTL kind of in the mechanism you're describing?
So that's for binding sets, there is no difference, right? It would be same. Like how, so the way the binding set is supposed to work is you are going to send FEC stack change from that point towards your, so when you discover that, this label is stitched to a set of different labels, you would send a FEC stack change.
Sure.
But the TTL value, it's just same as in 8029, right? I mean, you just continue incrementing the TTL.
So let's take R2 is the BSID. How do you get to the R3?
So there are different modes defined in 8029. There's one mode where you can trace the contained LSP when you are doing the FEC stack. I mean, when the FEC stack change is happening. There's another mode you can skip tracing and you can trace both the options. And then RFC 8029 defines how exactly the tracing works, right? So the TTL for the TTL value, if you want to trace it, it would just have to increment for the binding site, like you start from.
But binding site has no meaning at R3, correct?
Yeah, so when you switch binding site from, it's a swap operation basically, right? So what do we do for swap operation for the TTL values, right? So I think we copy from this label and then reduce it by 1. That's how it gets for the swap labels. So generally, if you just forget binding site for a moment, how does this TTL get copied from, like R2? There's a swap, label swap, right? It's going from, like, you have 1002, it swaps to 1002, and when it does that, it decrements the TTL by 1. I think that's the same way the binding SID. For the binding SID, like first hop, it just copies from the previous one, so it just, and out TTL will be reduced by 1, and then that's, and it continues from there. And then wherever you're popping the label, the same procedure would apply.
Okay. Can discuss offline.
Yeah, sure. Any other questions?
So any further questions? Bruno, do you have anything? Okay. Yeah, go ahead.
Orange. Anything about what?
No, I meant on those two drafts.
Not for me. On ONM?
I meant on those two drafts, if you have any comments.
So for the latest one, currently there is a significant extension to LSP ping, so I think it should be discussed in Mpls
Okay.
working group. It could be. It's also in the agenda of spring. But then if the comment from Aldrin is addressed on the extension is removed, we could discuss. Regarding the first presentation, it's also in spring agenda. To be fair, there is another draft from Zafar, which is very similar, which is in spring agenda also, and Mpls agenda in a different slot, the next one.
Okay. Yeah.
So clearly both drafts are redundant.
So what you basically say is that we need to do some type of inter-working group coordination here.
Yes.
Okay.
But spring meeting is tomorrow, so maybe tomorrow we'll have more data on that.
Okay. So Chadra, will you be in the spring working group meeting tomorrow? Okay, so I will make sure that I'm there also. Okay,
Yeah,
thank you.
no problem. Thank you.
We can close it down now.
That's it, yeah. So I think we are done for today. We have a second session tomorrow starting at, I think, 11:20. Yeah. So see you there. Thank you.
And there is a break soon, so it should be on this floor, I think. And then, okay. So see you tomorrow.
Hi. I saw you yesterday, but